Okay, so H is what's called a horizontal shift. And you guys I would not require you to know that, but it's called a horizontal shift. Horizontal, which means it's just moving left or right. That's all it means by a horizontal shift. And remember, when it's a plus sign, we moved left, and when it was a minus sign, we moved right. We should be used to this. We've seen this chart before, and a lot of you, I can see in your interactive notebook, some of you have it out, that green piece is coming out. So that K is that vertical shift, which just means we're moving up or down. Okay, that's this guy out here, this K value. That's when we were moving up or down. This guy here was that H value. All right, now if the A is negative, what was going on? What do we call that? Okay, so that's going to be coming up, but it's reflect. Okay, so when A is negative, we're reflecting over the what axis? Yeah, good. Okay, so we are reflecting over the x-axis. So if I have a negative by the equal sign, we're reflecting. Now is, Jacob, kind of what you're talking about. So when it's greater than 1, what are we doing?
When it's greater than 1,
we are stretching, and then, yep, and then we are compressing. Compression, a vertical compression. Okay? So like 1/2 would be compressing. And remember, if I take you and I smush you down, you get wider. Okay, I'm compressing you. If I take you and I pull you up, I make you taller, you stretch, and you get longer. Okay? Questions on that? All right, now we're just going to describe the transformations. Not too much of a difficult task here. So I'm going to kind of highlight just one little piece. This piece, this 2x, maybe box it because you guys don't have highlighters, and it's okay if you don't have one, it's fine. Okay, that's your parent function. It has nothing to do with transformation. It's called a parent function. It's something that is just what we're putting in the calculator, 2 to the x power, something called a parent function. But the 3 out in front tells us something. What is it? It does tell us a y-intercept, yes. But what else? It's stretching by 3. You are correct. You are correct, Jacob. It's also telling us we're stretching by 3. In terms of transformations, what about this 5 up here?
Going down. Right 5.
Yep, right 5. Very good. Now, again, I'll kind of talk about this a little bit. If the number is right next to the x, it's right next to it. It doesn't. Sometimes it's in parentheses. In these situations, it might not be because it's in an exponent. I don't really need it in parentheses. But if it's right next to the x, that means I'm moving left or right. If it was down here, like for B, that's moving up or down. So let's talk about this one. I'm going to box this piece because this piece has nothing to do with transformations. That's just what we call a parent function. That's the original. But the negative means something. What does it mean? Yeah. Awesome. What about this 4? It's okay. 4, yeah. The only one that's really weird and tricky is like the left and the right. Okay, that's like the opposite of what you would think. The plus is moving left and the minus is moving right. If you ever get stuck, you have that chart to refer to. Now, what does this 1/4 mean? Yep, compress by 1/4. Now, again, this little box, it means nothing. That's part of the function. This is our original. But what does a +1 mean? Very good. Left 1. And then this means down 7. Good. Okay. I think you guys are good at that because you've been doing it for so long. You've been doing it almost in every single chapter that we've done so far. Questions? Sure. Okay, we're only going to do a couple examples here. We're just going to plug in some values. Again, there are 3 ways actually you can do this. You can do it in your head, bless you. You can plug it into your calculator by putting in some values, or you can go to your graphing calculator and get all the values. All of those are acceptable, all of them. Just because I'm your math teacher and push you to always do stuff in your head doesn't mean you can't do it in your calculator at home. But right now I'm going to push you to do it in your head because that's just what I do. So here, let's put it in our head. I have 2 to the 1/3 to the -1 power. All I did was I plugged in the -1. That's all I did, right here. Plugged it in. Let's take it piece by piece. Again, you're more than welcome to put this in your calculator, but I challenge you to not do it right now. What does that -1 do?
It flips the position.
It flips the positions. So it now becomes what?
3 over 1.
3 over 1. Well, what is 3 times 2?
6.
6. Got it. So 6 is our answer for that one. Again, always more than welcome to get your calculator and type that in. Go for it. But I'm not going to do that with you here in for notes. So 2 to the 1/3, the 0 power. This is even easier. Anything to the 0 power is
1.
and 1 times 2 is
2.
2. Let's try it again. Again, I really just care about those 3 points. They're going to help us out a lot here. Let's plug this one in. 2, 1/3, all the 1 power. Anything to the 1 power is itself. So I'm just going to like cover it up. 2 times 1/3. Yeah, 0.66, which is actually just 2/3 because you multiply straight across. Again, more than welcome to plug that in your calculator. 2 times 1/3 is just 2 over 3 because you multiply only the tops. Because technically it's 2 over 1. I don't really care about the other points, so I'm not really worried about it, but let's graph those out. Oop, I'm going to go all the way down here. So I have -1 up 6. 1, 2, 3, 4, 5, 6. 0, 1, 2. And then 1 2/3 is like somewhere around there. Okay, and I'm just going to go ahead and graph that out. Oop, that looked awful.
And it never touches the x. Right?
Yep, it never touches the x. You're correct. Because it has an asymptote there. The only thing that's going to affect your asymptote is if you're moving up or down, which we're not here. Now, again, you could have gone into your graphing calculator and got all this information, but I'm just pushing you to do in your head. Now, am I growing or decaying?
Decaying.
I'm decaying, and that's from this point here. This 1/3 means decay. So if it helps you, draw an arrow so you know. So that's kind of what you missed yesterday if you were gone, was just this piece and this piece. That's it. And the rest is we're relearning. The only thing that's new today is the transformation part. So what's happening in the transformation? What does that 2 all the way out in front mean? I heard it.
Stretched by 2.
It is stretched by 2. Very good. So this green part right here, that means I am stretching by 2. That's all that means. Domain. What is a domain of all exponential functions? Yep, negative infinity to positive, which means all real numbers. That means I'm including every x value on this graph. There's no restrictions on it. I can't be like, oh, we didn't go in business on week 5. No, we were in business on week 5 here. Okay, the range, though. Bottom to top.
0 to infinity.
Yep, very good. 0 to positive infinity. And for those that got confused on that, remember we used to do this way back when we did range. I have no function here at negative, but I start at 0. And I go on all the way up forever. There's every y value, 0 and up, exists on this graph.
It's why you can't walk through a wall.
Yep, that's what an asymptote is. It's like you can't walk through the wall. And our wall here, talking about walls, is our asymptote is at y equals 0. It's always the y. And for those that weren't here, we kind of refreshed on what an asymptote was. And that's just a line or a wall. You can think of it as a wall where the graph never touches. Yeah, and then here it's y equals 0. And that's like this piece right here, at y equals 0, if you want a little sketch. Okay, it never touches it. And if you go ahead and you graph it, if you keep going down and down and down or going up and up and up of your numbers, you'll see that it never actually touches 0. It gets really close to it.
Would the y-intercept be 0, 2?
It would be 0, 2, right here. This is our y-intercept.
What if there was more than 1?
There will never be more than one y-intercept. Otherwise, it wouldn't be a function. Good question, though. All right?
That's fine.
Yeah, okay. So here's actually what we were just doing in my other class, in my first and second hour, which is a co-talk class. Limit statements and behavior. All it's telling you is your domain and range, which you already established. Okay, so if you know your domain and range, you should be able to identify your end behavior. It's really just think end behavior, it's the end, it's your arrows. Okay, it's the ends. Okay, so here if you look at this piece, this is what's really cool. Look at that, it's your domain. Do you see how the x is? It says as x is going to negative, there it is. As x is going to positive, those are your domain pieces. But here, remember f of x is always your range, always.
Would it be, if feels, so would it be to infinity and then negative infinity because it's going down? Like it feels like going up like this. Would it be up?
No, I'm listening.
I don't even know what I'm saying.
It's okay. Sometimes you just gotta talk it out. So,
So it would be 0 to infinity?
so kind of. Okay, so
Would it be infinity and then negative infinity?
we'll talk. Let me explain it first. So we know that our only answers, my only solution, will involve either 0 or infinity. They're my only two options. I don't know where they're gonna go, but they're gonna go in one of these spots. Okay, because it's describing the range. So here we go. As x is going to negative, here I am, my x is going to negative. Where is the function going though? In going to infinity. So it doesn't always go in the same order, but you use those pieces. Because now watch, as x is getting towards the infinity part, or getting bigger and bigger, you see how the graph is starting to slowly hit 0. It's starting to slowly hit the y value of 0. And that's why 0 is here. But if you notice, the range will always be represented here. Always. And the domain will always be represented here. Always. That's what limit statements are. It's a way for you to tell the reader or someone else what the domain and range are just in one statement. It's kind of cool. Now, am I always increasing or always decreasing in this situation? Decreasing. Very good. And again, if I'm always decreasing, I'm going negative infinity to positive. Look when you're ready. Maybe. I don't know if we do. All right. So based on your knowledge of transformations, what will a negative in front do? We talked about it earlier. What'd you say? It would decay if it was in the exponent, but it would reflect in terms of transformations. So reflect over the x-axis. Okay? Now what's nice about these is that the graph is done for us. Like, you should be excited when the graph's done for you because you have to really do nothing besides look at it and analyze it. So is it going to be growing or decaying?
Okay.
It's decaying. Very good. Now, a lot of people will fight me on that one because you said, I know, but a lot of people will fight me because you said, oh, Miss Abel, yesterday you told us if the number is bigger than 1, we're going to be growing. And I agree with you 100%. But then this negative comes in and flips it. And that's why it's decaying. Because when you read a graph left to right, it goes down and decreases. Okay? So the transformations. This negative means something. We already talked about it. It's reflecting. And what's happening with this 2 out in front? And we're stretching. Very good. Cool? What is the domain of all exponential functions? Yep, all real numbers. Now here's where the range comes in. A lot of people, I'm telling you, across levels. It'll,
0 to infinity?
a lot of, okay, you said it correctly, but like you had it switched. Do you think? In not just infinity to 0, negative infinity. Yep. Yep, that's where the wall is. So look, I start at negative infinity because that's where I'm at. It keeps going down forever, but then I stop. That's what the range of the domain is. You're telling me where does it start, where does it end? Where does it start and where does it end?
I was thinking like it started 0 and then 1 to negative 3.
I get that. It just, you have to go from bottom to top. Bottom to top, right, Tommy? All right. Now, where's my asymptote?
0.
It's at 0. Make sure you put that y equals. It's important. Your intercept. Where's it crossing the y? 0, negative 2. Very good. There are 3 ways you could have done that. You could have plugged it in. You could have looked here at that negative 2, or you could have looked at that point on the graph. Either one works. Okay, then I have my end statements. Again, the only thing that needs to be represented are these 2 numbers. You just have to figure out where they belong. So the range, it needs to be represented here. It's just where do they go? So as x goes to negative, where is the graph going?
0.
To 0. Good. You're getting better at that. That's awesome. So 0, and then the other one has to be negative infinity then. Am I always increasing or always decreasing? Good. Questions? Okay, lots of stuff going on here. And this one's important, and we'll be done here shortly. You guys are doing a fantastic job. You just have to, you're getting better at graphs. You've been doing a lot of graphing. After this chapter, we're not going to be graphing as much. Okay? We got a lot of algebra and then like real life situations. This would be compressed, so I have compress here by 1/3. What else is going on?
Left one.
Yep, I am going left 1. And what else?
Down 3.
And down 3 in green. You're right.
Be up 3.
Nope. The only thing that's opposite is the exponent, the left and right. So like originally you would think going positive would be going right, but really it's going left. Okay. Am I growing or decaying when I read the graph left to right? Yeah, good, growing. You see how it grows up, 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 up. Cool. Now the domain has not changed. What is it? Yep, all real numbers. Now, so this is where things get a little tricky because the moment that an exponential graph moves up or down is the moment you now change the asymptote.
So it would be -3 infinity.
Yep, it would be -3 to positive infinity. So normally it would be 0, but because we moved the whole graph down 3 here in yellow is my asymptote now. That's my asymptote. So my asymptote's at y equals -3.
So there will always be a boundary somewhere?
On an exponential function, yes, there will be a boundary.
Oh, -2. Y equals
Yeah, no, you know you got it. It's not 2/3 though. What is it?
half.
It's not 2/3. It's just what's on top of the 3?
2.
A 1. It's 1/3. So 0, 1/3. Remember, it's always that number all the way out in front. Or you can kind of guesstimate here. You could have been like, oh, it's like -2 point something. That's fine. Ooh, but it went down 3 though. Wait, hold on. Let's back that up.
That's what I said, -2.
Back that up.
Oh,
Make a little bit of a guess here. It's about -2 and 1/3. Yes, there you go. You could have just guessed there. Or you could say, okay, it's 1/3, but then I go down 3. Same thing. So you go down there. All right.
then the y
Now, let's talk about the end behavior. Remember, it's always your range. We just need to figure out which piece goes where. That's what our end behavior is. We just need to figure out which one goes where. So, as x is getting smaller, the function's approaching what?
-3.
There we go, -3. So it's kind of cool to make that correlate. And I've made that correlation in the past, but I don't think it clicked until now. That the range goes with that piece. And then that means that that infinity one goes over here. I'm going to put like a little arrow so you don't forget that's where that's coming from. That's not an arrow, that's just a blob. Am I always increasing or decreasing?
Increasing.
There you go, and we're done.